Today we're going to do our very first lesson, and it's called Algebraic terms. And you're going to think, gosh, this seems familiar. It is. You've been doing this for several years. You think, well, why are you making me do it again? Because it's been a couple months since you did any math at all, and we want to make sure we got it, we remember. All right, so when we talk about like terms, those like terms have the same variables with the same exponents. All right, so let's refresh our memory. You don't have to write what I'm about to write on my Post-it note. We're just talking. Like terms have the exact same variables and the same exponents. If I give you 4x and 5y, are those like terms? No, why not? They don't have the same variable. One's an x, one's a y. All right? What could I do to 5y to make it be a like term for 4x? Just drop off the y, change that y to an x. Now are they like terms? Okay? What if I did this? They both got an x, but why not? They don't have the same exponent. That's a 3. Now, somebody's going to argue and be like, it don't have an exponent. It does have an exponent. What is it? It's a 1. So you don't have to write the 1, but we have to remember that's a 1. Okay? So, when we combine our like terms and we add, subtract, sometimes they make us multiply, we have to make sure we write them in standard form. Okay? Standard form is in descending order. If you're going to descend a mountain, where do you start at? The top, and you go down. When you write terms in standard form, you start with the highest exponent, and you go to the lowest exponent. So in my little example right here, which one would go first? Would it be 4x or 5x to the third? 5x to the third. Now, why should 5x to the third be in the front? It has the highest exponent. It has nothing to do with that coefficient. Okay? All right, so let's remember. If we're going to add or subtract terms, you add or subtract the coefficients. Now that's the proper mathematical term. What's the coefficient referring to? The number in the front. So, if I tell you 7x to the 12, which of these numbers is the coefficient? The 7. That's in the front. What's this guy called? That's your exponent, okay? All right? Now, if a coefficient is missing, so like you don't see it, but there is a variable. So if I give you a, if I just give you a, variable a, what's the coefficient there? A 1. Why is it not a 0? Because if it was 0, what's 0 times anything? 0, so the a would disappear. So if it looks like it's missing and it's not written, it's either positive or negative 1, depending on the sign in front of it. So coefficients take the sign in front of them, of the variable, of the coefficient. All right, so let me give you some examples. Now, don't say it out loud. I want you to think it in your head. You don't have to write what I'm writing on my Post-it note. All right? I'm going to put this on my paper. You're not writing, you're just thinking. I want you to first think, are those even like terms? Now, don't tell me. Remember, we're thinking. You're thinking, are those like terms? Because if they are like terms, I could add or subtract their coefficients. If they're not like terms, then I just say, can't do nothing with them. You've got a 3x squared and a 4x squared. Are they like terms? Yes. Why? They're the same variable with the same exponent. So, if you got 3x squareds and I've got 4x squareds, that's just like if I say you got 3 apples, I got 4 apples, how many we got? We got 7 apples. Notice you didn't say all of a sudden I got bananas. Your x term, your x squared is going to stay the same. So if I said let's go 9b to the third minus, I'm going to make the math easy in our brains, minus 5b to the third. Are these like terms? Yes. So what do I do with the numbers in the front? I subtract. 9 minus 5 becomes how many? 4b to the third. Just like when you're helping your little brothers or sisters, or maybe you might have some nieces and nephews that are like learning to add or subtract in what, kindergarten, first grade? You tell them, what word do you usually say? You've got 9, and then what do you do when you subtract? You take away, okay? So that's some ways you can help your siblings and your cousins, all right? You don't change the b to the third unless you are multiplying. That's when something changes. All right, let me give you a little bit bigger one I want you to think about. All right, I got 8x to the third plus 7x squared plus 2x to the third. You've got 3 different terms. Are they all like terms? No. Do you have any like terms? Which ones? 8x to the third and 2x to the third. So what does that become? 10x to the third. What do you do about this guy? You just bring him down. Why can I not say 17x to the something? They're not like terms. Now, you say, Miss Slusher, I got this. You do. It's when I throw and multiply with it that things start to get a little overwhelming. Okay? All right. So here's what we're going to do. We're going to do a couple of examples. I know I left that blank. We're going to come back to it. All right. So in example 1, you stay with me. Don't go ahead. I've got all these terms. I have to write it in standard form, so what I do is I start with the highest exponent. Now I'm going to use some different highlighters to color them. You can do that if you want to. You don't have to. I just want it to stand out. Then I'll show you how I just do it with underlining. All right, look at all of your exponents. That's x to the first, no exponent, x to the first. That's a constant number, no exponent. X squared, constant, x squared, constant. What is your highest exponent? X to the second. All right, so here's what I'm going to do. To the second, I take the sign in front. So 2x to the second. Here's a second, so I take the sign in front. So I colored those pink. I hope you could see it good on my thing. Those are the only x squareds I got. So let me grab a calculator, because sometimes negatives try to trick me. Okay? All right? So if I want to, I can't put the x's in the calculator. Well, let me rephrase that. I can't put the x's in the calculator and it do what I want. I can put an x in a calculator, but the calculator's not programmed for that, so it's always going to give you a wrong answer. All right, I've got negative 4 of those plus 2 of those. What's that going to result in? Negative 2. So I'm going to start out with a negative 2x squared. Okay, now you could mark them off if you wanted to. All right, if we're going in down descending order, if we were at x squared, what's 1 down from x squared? Go too far. X to the first, 2, 1. All right, highlight or underline everything, including the sign in front of the x's. When it's x to the first, that's actually called a linear term. We'll learn more of that tomorrow. All right, what am I going to do? I've got 3 terms, so what do I do with those 3 numbers? Add them up, okay? I can do it in my head if I want to, okay? So negative 2 and negative 4 gives me negative 6, and negative 6 plus negative 15 more gives me negative 21, I'm pretty sure. I'm going to check my calculator just because my brain is kind of tired today. So negative 2 minus a 4 minus a 15, we were right. Negative 21, but what goes behind it? Just x. When you add or subtract, you don't change anything at all about the variable. All right, so then that leaves me with only a bunch of constant numbers. Constants have no variable at all. A variable means something can change. If you have a constant, that means it stays the same. So, real life info, okay? If you get a credit card or a loan and you have a variable interest rate, guess what that means? it can change from month to month. I mean, it can go up, 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 up. If you have a constant, sometimes the car companies will call that a fixed interest rate. What's that mean? Stays the same. There's nothing they can change about it. All right, so let's combine all of my little teal colors. All right, so I can do it in my head. I can do 3 plus 5, which is 8, and 11 more is, yep. And then take away 15 gives me 4, I think. But sometimes my brain just don't work, or negatives make me nervous, I'm going to be honest. If I'm going to mess up, it's because of a negative. So 3 plus 4 plus 11 minus 15, we were right. 4. Why doesn't that 4 have an x? Because it's a constant. It didn't have an x to begin with, so it doesn't have one. All right, so I'm going to show you a way you could do example 2 without highlighters if you don't have all the colors. Another way I do it, I still start out looking for my highest exponent. Look at all my exponents. I see a 3. That's not higher, that's the same. What's the highest exponent I got? 3. All right, so I'm going to start with those. I have a 2x to the third and a negative 3x to the third. So I underline those one time because that reminds me they go together. Now, you are welcome to highlight if you like to highlight. I love color. Color makes it so much easier for you. All right? Now, what is 2x thirds minus 3x thirds? Negative x to the third. Now, what's another way you could write this and mean the same thing? Negative 1x to the third. We're both right. Okay? So now, here's what I'm going to do. I'm going to cancel them. I'm going to cross those out. What's it mean when I cross them out? I'm done with them. That way I don't accidentally use them again. All right, so you're thinking about going down steps. If you were at 5, 4, 3, where do you go now? 2. Look for all of the 2's. I'm going to give those 2 lines. What's in front of this x? A 1. If it helps you to put the 1, do. You're right, a plus, so that means it's a plus 1. So it's a positive 1. What's positive 1 take away 3? Negative 2x to the square. So I'm going to mark those off because I already used them. All right, keep going down. You went 3, 2, what do I do now? X to the first. So I've got x to the first, so 1 of those, then 2 more of those. So what's 1x plus 2 x's? 3x. Plus 3x. And remember, when we add or subtract, we don't change the variables. And then all that's left are my constants. So negative 9 and negative 2 is, all right, and negative 4 more? Negative 15. Can any of these combine together? Are any of these still like terms? More than likely, you're going to have somebody argue that these could go together. They're both x's, but why can't these go together? They got different I'm about to call the wrong thing, exponents. Now, I want you to put like a rectangle around your answer because that tells me when I'm grading your work and it tells you this is my answer. It makes it a whole lot easier for us to check our work. All right, I want you to try one on your own. So, don't keep going. I just want you to try number 3. So you try number 3. And what I'll do after just a few minutes is I'm going to write the answer down here so you can check your work. Don't steal my answer. You do it, and you check your work. All right, so once you had a chance to do it, this really is your final answer. But I want to explain it to you. So we look for the highest exponent. So in that case, I'm going to go back to using my highlighters because they just make me happy. The highest exponent is x to the third. So it's a positive x to the third. So notice that every time I highlight the sign in front of it. That's the only x to the third, so that's where 2x to the third comes from. All right? X squared. I see a square, that positive is in front of it, so a plus 5x squared, a plus 4x squared, and that's the only one. So 5 plus 4 more is how you got a 9x squared. All right, so now let me highlight my x's. I've got 4 x's, positive 2 x's, And minus, how many x's is that? Oh, well, total, yeah. And then 1, so for a total of 3. Or not 3. I gotta take away that 1, so 4 minus 1 would be 3, plus 2 more is gonna give me 5 x's, okay? Now, don't forget, don't be too lazy to type that in your calculator. You got 4 plus 2 more minus 1, and that gives you a total of 5 x's. And then finally, we have our constants that don't have an x. I got -3, I got +8, and I got -9. Now, I'm going to be honest. I told you, if I'm going to mess up, it's with the negative. So I'm just going to type a -3 plus an 8 minus a 9 to double check that it really is a -4. Alright, so we reviewed add and subtract. Let's flip back over. Because if we remember correctly, our multiply rules are just a smidge different, okay? So, when you're going to multiply terms, you multiply the coefficients together. So, the numbers in front, you multiply those together. And then you actually add the exponents of the same variables. Alright, I'm going to show you how sometimes you can't remember if you're supposed to add or subtract the exponents or maybe multiply them. Here's what I do, okay? What I write on my post-it note, you don't have to write down. If I give you x to the 4th times x to the 3rd, how many x's is x to the 4th? 4. 1, 2, 3, 4. That's x times x times x times x times x to the 3rd. So what's x to the 3rd really mean? 3 x's. Okay, now, how many x's do you have multiplied together? 1, 2, 3, 4, 5, 6, 7. What do you do with 4 and 3 to get to 7? You add them, okay? So if I'm ever not sure, because on a test or a quiz I can't ask my teacher, I just draw out my example. Alright, so what if I gave you, I'm going to use a different variable just to prove to you it's fine. I'm going to use m to the 5th times m to the 9th. Okay? So what this is telling you is you have 5 m's, you're multiplying 9 more m's for a total of what? You take 9, put 5 more with it. What's 9 plus 5? 14. So it would be m to the 14th power. Okay? Well, what if I throw a number in front? If I have 5x squared times 3x to the 4th, here's what that actually means. It means 5 times x times 3 times 1, 2, 3, 4. What's 5 times 3? 15. How many x's? 1, 2, 3, 4, 5, 6. Instead of drawing out all the x's, what could I have done with 2 and 4? Just add them together. If you multiply the variables, you add their exponents. Okay? So, let's try a few of those on the back. Alright. So, what's this dot mean? What's it mean when you got 2 parentheses side by side? Multiplication. What about a number or a term and then just 1 parentheses? Multiplication. All 3 of them are multiplication. Okay? Now, you say, Ms. Flusher, you forgot about the little x. True. You can't put the little x, but since we're using variables, I'd stay far away from the little x because I might think it's a variable. Alright, so this is going to sound like a smarty pants question and answer, but it's not. Is this add, subtract, or multiply? Multiply. How'd you know? Because of the dot. Now you say, why did you ask me that? Well, it's because if it's add, subtract, you do one thing, and if it's multiply, you do another. So, since it's multiply, I'm going to multiply my numbers. What is 5 times 2? 10. If I have x to the 3rd times x to the 4th, what do I get to do with those exponents? Add them together, so 3, and then 4 more makes x to the 7. Alright, let's look at this one. Is this problem trying to get me to add, subtract, or multiply? To multiply. And if I need to look back at my rules, when I'm going to multiply, I multiply the coefficients, and then I add the exponents of the same variable. So coefficients are in front. What is 7 times a negative 4? Negative 28. All right. X to the second times x to the fifth. How many x's is that? X to the 7. All right. I'm going to pause while you try these two. And then in just a second, I'm going to show you the answer so you can check your answer. All right, so here you have the two answers. All right. Now, one thing that tricks people is your negatives. That's a negative sign. So a negative 10 times a negative 8 is a negative 80. Okay? What would it have been if this had also been a negative? So like negative times a negative would have given you a what? A positive. If you're not sure, type the numbers in your calculator. So 7 and 6 gave me 13. Here, how many x's is this? It's 1. Okay? I had a student in the past. She kept getting them wrong because she would think it's not there, it's 0. The minute she started putting the 1 there, she reminded herself it was 1. She got them right every time. If that helps you, you do it. If you don't need to, that's fine. So I did 3 times 11 and got 33. X to the first and another x to the 8 gave me x to the 9. Now, you did great when it was add, subtract together. You do great when it's multiplied by itself. Where sometimes we mess up is when all of a sudden now I got a whole bunch of numbers and letters and signs all mixed together. How am I going to know if I'm supposed to multiply? It's going to have a dot or some parentheses, okay? If it's add and subtract, I'm just going to combine like terms. So here's what I want you to do. I want you to try all 6, okay? I'll have the answer up there so that you can check as you go. But notice I said check as you go. Don't you steal my answer. You do your work, and then you check. If you're too tempted to steal my answer, don't look up here till you're done. All right, so here's the answers to the independent practice. Hopefully you got all of those answers. This is the common mistakes I see. Not that a single soul in class today made them. This is what I see as a teacher over the years. All right. We were doing, when we add and subtract, do you mess with the exponents? No. What's the only time you mess with the exponents? When you multiply. Well, we get so used to multiplying and mess with the exponents that we accidentally sometimes mess with the exponents. Add and subtract, only the coefficients, okay? So what we did here was we had negative 5 and positive 2 gave us a negative 3x squared. Then we had a 2x minus a 1x plus a 9x to get 10x. And then our constant 7 minus 11 gave us a negative 4. But when it came time over here, that's a multiply. So I do 9 times 3 is 27, and I have x to the 7th times x to the 2, which means 7 multiplied together, multiplied by 2 more, gives me a total of 9. All right? Right here, how would you tell a classmate that that's definitely multiply? The parentheses. You got one term right up against a parentheses means to multiply. So I multiply the coefficients, add the exponents. How do you know? Now this is going to sound like a smarty pants question. How do you know this is not multiply? There's no parentheses in there that means to multiply. There's no dot. So we look for our highest term and we add those up. Now, somebody might say, where do a squareds go? That's a great question because I see a squared in the original, but I don't see a squared in my answer. I had a negative a squared and a positive a squared. What's negative 1 plus 1? 0. So they completely go away. All right? Now, the only other thing I'm worried about that I would predict if I was grading this that somebody might mess up, they might have a negative right here. Why is the 48 positive instead of negative? Two negatives multiplied together make a positive. So negative times a negative is where we got our positive. us up what we need to remember, which was, if you add or subtract terms, you're going to add, subtract the coefficients, and keep the variable and the exponents the same. If you multiply, you're going to multiply the coefficients and then add those variables.